So let's talk a little bit about cloud computing.
And you pretty much end up with having a technology that could end up being, for the next 10 to 20 years, the foundation of solving many of the applications.
The thing is that there is no question but that the cloud is real. Enterprises are adopting it on a daily basis, and an increasing percentage of applications is moving to the cloud.
We all recognize that we are sharing common resources when we're using the cloud. And all of the advantages of that is that we don't have to pay for the capital cost of the entire cloud. We only have to pay for our usage of it.
You know, we have to imagine that these kinds of federated systems are going to attract private infrastructure owners who want to join their infrastructure into a collective.
On the opportunity side, it's been possible to very dynamically allocate large amounts of computing power against a particular problem until that problem is solved, whatever it is. Might be a search in the case of Google, or some other, maybe many people simultaneously doing their Gmail. It could be people doing documents. Today it could be people downloading or uploading video, or it might be somebody doing a Hangout, which is our word for video conferencing. All of that stuff is possible because of the amount of compute power and memory that's available in the cloud.
Thinking about how big data relates to cloud, there are a number of ways, and probably the first, although it isn't as mature as many of the others right now, is data as a service. So if you think of cloud as X as a service, increasingly we're starting to see companies providing data. Probably a poster child is location data that can be used by others as a service, just as any other service. So in some sense, big data is a cloud offering in many ways. But the way people usually think of big data and cloud is that cloud is a way of doing very heavyweight processing on lots of data that may have spikes, may change fairly dramatically, and very importantly can be parallelized.
Well, this is a very exciting time in cloud computing and various other areas, you might say, surrounding it, because we have a lot of new standards and software for being able to, that allows us to access resources, generally computers, networks, not just computers, but also networks and storage, different kinds of networks. And people are beginning to deploy and operate these on campuses and in companies, and as well as the public clouds like Amazon's Elastic Compute Cloud is one that many people know.
People that look at the benefits of the cloud normally focus on cost reduction and business agility, and there's no question that those are important. But in addition to that, customer experience is critical, because ultimately customer experience directly correlates to revenue and thus profitability. In addition to customer experience, there's user experience for internal employees, and so the interactivity and response time of applications then drives labor productivity, which is of course a key metric.
This is one of the things that distinguishes cloud computing from traditional time sharing, where you have one machine somewhere that everybody is sharing, and there's efficiency in that. And there's certainly a cost benefit because you only pay for what you use, so to speak. But in the absence of having replicas and having the data also replicated, the failure of one time sharing system can be very devastating. So the cloud offers, just by its very design, an opportunity to preserve information and computational capability across enough space, if you've implemented it properly, to overcome a lot of the likely failures, concurrent disasters that might wipe out all of a data center or all of a cloud operation.
The cloud can go into hundreds of different vertical markets, human resources, financials, and every one of them, in terms of, let's say, a quote to cash or service maintenance process, you have different application that goes across every one of them. And you need to be able to make sure that every application can move into the cloud with those three levels of parameter that I talked about: quality of service, class of service, and the security.
We have to look at the cloud computing opportunity holistically. So we need to bring all the resources we can to bear, whether they be within the computer society or within the standards organization or within the communication society. So we need an initiative like the cloud initiative, very similar to what we did with Smart Grid. That's been tremendously successful, and I think we have to copy that success.
Well, it's exciting to think about the capabilities and possibilities with cloud computing and communications in terms of the flexibility and opportunities it will enable to provide. And then as far as the technical people working on, myself and others working on these topics, it's exciting in terms of technical challenges and looking for ways to solve these important problems to enable the future.
The fact is, it's here. The cloud is here. And it's being used by people, by consumers, just like myself. I mean, I experience the cloud every day. I use Dropbox, for example, on my iPhone, my iPad mini, my MacBook Air, my PC.
It's pretty clear that the cloud doesn't solve everyone's problems in the universe, and in fact that what we're going to find is a mix of legacy applications, private clouds, public clouds, and so with all that, interoperability becomes critical and standards become critical and mechanisms for federation and identity and network connectivity to make it all work together. So
I use it when I watch TV, streaming television, streaming movies. I use the cloud for my calendar, for my email, for just about everything. And I think it really is here.
There's still some challenges ahead. Or you could view it as there's still huge opportunities as the cloud continues to evolve.